Assalamu alaikum. Acha, now we have a continuation of our lecture related to the homogeneous and the homothetic functions. Okay, so we have concluded here that the Cobb-Douglas utility functions will be the HOD 1, homogeneous of degree 1. Okay, so please. Okay, so yeah, so let's say Z equals to alpha T L and T K.
So L and K is labor
L,
and capital.
labor and capital, and if K, HOD R. Okay. So in case of production, in case of production, Z T L T K T E power R F L K are greater than 1, HOD are equal to 2, HOD 2 IRS. Okay, increasing returns to scale, right? And similarly, TRF LK are equals to 1, HOD 1 CRS, right? And similarly, less than 1 means K 1 over 2 DRS. Okay, DRS. Okay, for example, if the power of T is equal to square, so equal to 2, that is actually the HOD 2, though IRS and CRS and DRS, decreasing returns to scale. So there are three possibilities in case of the production functions. Clear? So as far as homothetic function is concerned, clear? So it means that homothetic functions may have a degree greater than 1, 2, or less than 1. Clear? So it may have a increasing returns to scale, decreasing returns to scale, and constant returns to scale. Clear? So it means कि I can plot it here कि homothetic function, right? So it is, for example, your f and f of x. This one IRS, am I right? Okay. Sorry, CRS, IRS, and what about this one is DRS. Clear? ऐसे ही होगा. Increasing returns to scale, decreasing returns to scale, and the constant returns to scale. So there are multiple possibilities here. So and you can apply. So HOD 2, HOD 1 is HOD 1 upon 2. Okay. So homothetic function may have increasing returns to scale, decreasing returns to scale, and constant returns to scale because it may have HOD 1, HOD 2, and HOD less than 1. Clear? So it is the case of theory of production, not the debate related to the consumer theory. That is actually the difference between homogeneity and the homotheticity of function. Clear? Okay, now move forward. Take one numerical example. Okay. For example, that fxy equal to x cube plus x square y plus xy square plus y cube. Clear? Okay, just scale with the lambda or the t. Okay, so f lambda x and lambda y. So it will be lambda cube x cube plus yes what lambda square and lambda, again you will have the lambda cube x square y plus lambda cube x y square, and again you will have the lambda cube y cube. So we can factor out the lambda here. So it will, you will have the functional value of f. Am I right? So that is actually the function of HOD3. HOD3. Okay. So, sir, wait. Say it is HOD3, right? That is the function HOD3. Now, similarly, if you cannot factor out this value here, excuse me, sir, class
क्लास कौन सी हो रही है
क्लास
यहाँ पे आप कैसे क्लास लेंगे भाई हैं मीटिंग करनी है मेरे को
अच्छा
हमारे क्लास में
ओके ओके so now that is actually the HOD3, and if you are not able to factor out this value from the function, so for example, we can write this value z equal to f of x y, and it is square plus x square y and plus x y square plus y cube, right? So in this condition you cannot factor out lambda completely from here because you have x square here. So the maximum value of lambda which you can factor out, it will be lambda square. Am I right? So finally you will have the factor x square plus again the lambda x square y plus lambda x y square plus lambda y cube. Am I right? You will have finally this function. So in this condition, that function is not homogeneous of any degree. Clear? Because we cannot factor out lambda here. Okay, so this is not homogeneous function. It is not homogeneous function. Clear?
Because we cannot factorize it.
Factor out the value of lambda, or which that factor which by which you scale up or down. Clear? We have scale up or down with the any scalar value lambda. Clear? Which is greater than equal to 0. The lambda greater than equal to 0. Clear? So you cannot factor out this one. So if you cannot factor out, so ultimately that function will not be a homogeneous function, first of all. Clear? So अब now one important statement. Okay. So deductions here. One important institution is here. Homogeneous function will be homothetic. But but vice versa is not true. Homogeneous function will be homothetic, but it is not necessary that every homothetic function will be homogeneous first. So vice versa is not true or not necessary. Clear? जरूरी नहीं है. Second, non-homogeneous homogeneous function non-homogeneous function non-homogeneous function becomes homothetic if and only if non-homogeneous function is is strictly increasing transformation strictly increasing transformation of function. Okay, so it is very these are two technical statements, and we will try to prove that okay, homogeneous function will be homothetic, but it is not possible or necessary true that every homothetic function will be first homogeneous. And second statement is that non-homogeneous functions become homothetic if non-homogeneous functions is strictly transformation of transformation of function. Clear? We will discuss in detail. Okay, if function overall is not homothetic, sorry, homogeneous, what does it mean this statement? Function is not overall homogeneous, but if that function is increasing transformation of homogeneous functions will be homothetic. What does it mean? It means we have talked about the increasing transformations when we have the exponent of the functions. Yani if we apply the exponential power to the functions, so exponential is increasing functions always. We have discussed in previous class. Similarly, we have discussed in previous class the log of function if the value of base of log is greater than 1. So it always be a increasing functions. We discussed in the previous class. Clear? So we will try to prove कि how you can prove the non-homogeneous functions may be a homothetic, clear, or how the homogeneous function is homothetic, clear. So we have to prove these two statements, intuitions. Now move forward. For example, fx is homothetic and it is not homogeneous, clear. But f f is consist of two functions, that is composite or compound function, or compound function. That is HOFX, clear. We discussed in previous class, right? And H is strictly increasing function, and fx is homogeneous of degree, homogeneous of HOD R. We don't know what is the degree of homogeneity is here. Yes, so the function is homothetic. How you can define this? So there are two. Condition one, condition one is what? F of x is equal to f of y. अच्छा, अब what does it means this one? First of all, let me clear you. क्या कह रहा हूं मैं भाई? Now the ln x alpha and y beta, clear? So it is not HOD function. It is not HOD function. Non-homogeneous. non-homogeneous. Why you cannot factor out lambda is here? Clear? Because of ln. But what about the ln? Ln is increasing in nature. Okay? This ln is increasing function. Okay? Ln is increasing function. Okay. For what? Ln is increasing function of what? Of HOD function. Because this one is HOD. It is HOD. Am I right? Homogeneous function. So I can write that. So this statement is clear. Now what? Fx is homothetic and it is not homogeneous, but fx is consist of two functions, that is composite or compound functions. It is kind of the composite and compound function. Clear? That is h of fx. Hof भी कहते हैं. H is strictly function. H is strictly function. And fx is homogeneous of HOD, homogeneous of alpha plus beta. Clear? So overall function is homothetic. Overall it is not homogeneous, but you can say that it is homothetic. So that was the meaning of this statement is here. Clear? Okay. Now there are certain properties of homothetic functions which we are discussing here. Number one condition in the properties of homothetic function. First of all, one condition, f of x equal to f of y. That condition should be satisfied. And we can write this one, h f of x, that is equals to h f of y. Clear? So, and second condition is here. Okay. Okay, now first of all, sorry. First of all, just write it here, case 1 and case 2. Let me one thing. Clear? Yes, first of all, write the definition of homothetic. Let me clear. Definition. Definition what? F is homothetic if and only if fx equal to fy implies that ftx equal to fty. This is the definition. Okay, how you can define it? We are saying कि x and y belongs to S, and x equal to again x1, x2, and so on xn. Similarly, y equal to y1, y2, and so on yn. Clear? Yes. y1, y2, and yn. Okay. Select any two values from x and y. And when it will give the same functional value, what does that mean by the first statement? Clear? Yani, if we calculate the functional value with respect to, for example, x1, clear, and with respect to y1 from x and y, both give the same value, clear, and when we scale these values of the domain with any scalar number, again the answer, the functional value keep the same. So it means that function is homothetic function. It is the meaning of this statement. What does it mean? मैंने कहा कि भाई मैं यहाँ लेता हूँ x की वैल्यू क्या है, मैंने कुछ भी ले ली कि यहाँ से ले रहा हूँ मैं, ये चल रहा है 2, 3 एंड कुछ भी वैल्यूज चल रही हैं, क्लियर। इस पे मैंने ले लिया, लेट्स से यहाँ ले लिया 1, 3 एंड 5 एंड सो ऑन, समझाने के लिए ले रहा हूँ, क्लियर। अब मैं फॉर एग्जाम्पल व्हेन आई सेलेक्ट, क्लियर, 2 unit from x and 1 unit from y, so my functional value does not change. What does it mean the functional value does not change? Because normally in case of functions we talk about the Cobb-Douglas functions, clear, or means we talk about utility functions. So that Cobb-Douglas functions and the utility functions based on the IQ and IS, am I right? Which is in the mathematical terms are called the level sets. We have discussed in previous lecture, clear? So when the level sets keep same on different values of x and y, the level set is same until and unless we change the scale, clear, yani we multiply these number simultaneously by 2 or 3 by any numbers, so again the level set will change. So that level set again you will have the on both number will on the same level set, so the function is homothetic. अब कैसे मैं बताऊंगा, देखो क्या कह रहा हूं, इसको जरा माइंड में रखना, ये मिटा दूं,
Yes, sir.
अभी क्लियर हो जाएगा। देखो ये स्टेटमेंट में यहाँ लिखा रहना ताकि क्लियर हो तुम लोगों को। मैं ये कह रहा हूं कि भाई एक मैंने फॉर एग्जाम्पल ये बना रहा हूं, right? Now this is x, right? So this x, x1, x2, xn, clear? Commodity vector, clear? और नॉर्मली अगर मैं यहाँ लिख देता हूं Okay, this is x1 commodity vector. Clear? x1, x1, x1. See? Clear? And this is called your x2 commodity vector, right? So we can write this one x21, x22, x23 and xn3. Clear? ऐसे ही होगा commodity vectors. So up now, so again you will have the multiple commodity vectors which is moving in n dimensional space, and again this is moving in n dimensional space. Okay. Up now, for the sake of simplicity, we consider that we focus towards the two-dimensional. ठीक है, to plot the level sets, right? So हमने यहाँ पे एक level set plot किया, and that is are the level sets. Okay, it is the level sets. Level set or what? IC or IQ or IQ. Am I right? Okay. Okay. And we select what f x y equal to 100 and f x y equal to 200. Okay, if f x y is 100, which lie on this level set. Clear? So fxy when it is equal to 200, so it will be lie on higher level sets. Clear? According to the utility function and the production function. So यहाँ हम कह रहे हैं कि that is actually what f, यहाँ मैंने लिख दिया, it is equal to 100. Clear? ये 100 है. अब now how you are utilizing this 100, हमने कहा कि भाई for example now we have 5, and for example this is yeah, this is 10. So what about this one? 5 and 10. Okay. And this is एक arbitrary ले लेता हूँ. Okay. अब now what I just want to explain you. For example, let's we multiply with 2. What does it means? क्या मतलब हुआ भाई हमने we have selected any arbitrary number from these bundle of choices 5 10. Clear? You have the level of utility and the level of satisfaction is 100. Am I right? And again when we select, for example, it is 8, sorry, 8, not 10. When we select 8, 7 and 8, 7 and 8, again you will have the same level of outcomes or utility and whatever, it is 100. Clear? As per the definition of your level sets or your utility function or your production function, यही होता है हमारे पास. तो हमारे पास सेम आंसर आता है. And when what we discuss, so this condition is going to be satisfied. Am I right? Any values, select any combinations, यानी मैं कोई भी combinations लूंगा, right? So you lie on the same उसके ऊपर, तो any combination, so that condition is going to be satisfied first. What does that mean? When we change or scale these number with any scalar number, clear, 2, 1, 3, 4, whatever, we multiply by the 2, for example. So our answer is, that is actually the, for example, 10 2s are 20. Clear, ये 20 हो जाएगा, 2 से कर रहा हूँ मैं, 20 यहाँ एक for sake of understanding में यहाँ ले लेता हूँ. ठीक है, ये मैंने ले लिया 20 and this one is 10 and it is 10. Clear? So 10 and 20 मैं यहाँ ले रहा हूँ. So this is for example the 10 and 20. Okay, this one. So what? 10 and 20. Clear? And again, we multiply this number as well because the same operation is applied here. Clear? Multiply scale by 2 and similarly multiply by 2. So this value become, for example, is 14 and 16. Clear? तो यहाँ पे हम ले लेते हैं, for example it is 14 and 16, यहाँ कुछ ले लेते हैं. ठीक है, so this is 14 and 16 and 16 something like here, for example मैं यहाँ ले लेता हूँ. Clear? So that was 10 initially ना, so 14 and 16 यहाँ ले लेता हूँ. Again this is 14 and 16, or again, right? So both lie on the other IC curve. Clear? Both lie on the other IC curve and no change in, for example, अभी आपके पास क्या हुआ कि it is the level of utility which is equal to 200 after change the scale. So the function is homothetic. Clear? So that condition is going to be satisfied. You got my point? So that is the technical difference between homogeneous and homothetic. क्लियर? बिल्कुल, कि हमने उसको क्या किया, जब हमने उसको चेंज किया तो हमारा ये नहीं हुआ, जब हमने दोनों को कोई भी दो आर्बिट्री पॉइंट्स पे जब कंडीशन सेटिस्फाई हुई उसको हमने स्केल अप किया, तो ऐसा नहीं हुआ कि एक वैल्यू किसी और आईसी पे लाई कर जाए, वो किसी और आईसी पे लाई कर जाए. अगर ऐसा हो जाता तो फंक्शन इज नॉट होमोथेटिक. क्लियर? यानी दैट वैल्यू डज नॉट लाई ऑन द सेम आईसी कर्व which that value lie. Clear? So function is not homothetic. It is my argument is here. So both should lie on the same IC curve. So in this condition the function is homothetic. Clear? So this is the definition of the homothetic functions. How numerically we can solve, prove, take some example is here. Clear है? ठीक है? Clear है भाई? So conclusion is here. When two choices of bundles satisfy the condition of homotheticity. Homotheticity means lie on same level set. After scaling up or down, again,
Sir, up and down means increasing, decreasing.
हाँ कम भी कर दोगे,
Okay. मतलब
डिवाइड बाय
like,
2, डिवाइड बाय 3, कुछ भी कर सकते हो ना, कम जी कर सकते हो, ठीक है. सो आफ्टर इंक्रीज और डिक्रीज, तो द लेवल ऑफ, यानी द लेवल सेट्स शिफ्ट डाउनवर्ड because indifference curve shift downwards when level of utility decreases, or indifference curve may increase when the level of utility increases, but after scaling up and down they always lie on the same level sets, ठीक है. So again they lie on the same level set. It is called homothetic function. ठीक है. It is called homothetic functions. So अब देखो, yes. So one, so the case number one, case number one. HOD hold then now proved. Given that fx equal to fy, condition of homotheticity, fx equal to fy, okay, and fx equal to fx is HOD, then ftx equal to T or fx. We know that fx equal to fy है, so replace with this one. So now tr into fy ये हो जाएगा, इसको अब मैं ऊपर लिख रहा हूँ, यहाँ पे लिख रहा हूँ, इधर लिख रहा हूँ, yes, so it is f tx, इसको अंदर ले जाऊंगा, सो ये f ty के बराबर हो जाएगा, प्रूव्ड। देखो क्या किया है, फर्स्ट कंडीशन एवरी होमोजेनस फंक्शन इज होमोथेटिक, ये हम कह चुके हैं ना कि होमोजेनस है तो होमोथेटिक होगा। सो z is a function of fx would be the HOD. When it is HOD, then it's imply f of tx, t is a power of r f of x. Clear? Factor out होगा, we have concluded. It must hold for homotheticity. क्या hold करना चाहिए? This condition. यही था ना हमारे पास, HOD हो गया, उसको ये hold ये करना चाहिए। अब कैसे करें? अब इसका मतलब ये ना, द फर्स्ट कंडीशन सेलेक्ट करी, फर्स्ट कंडीशन ऑफ व्हाट, f of x equal to now proof क्या किया भाई, गिवन दैट कंडीशन fx equals to fy, ठीक है, पिक दिस वन, इसको पिक किया फंक्शन को, इसको HOD प्रूव करने के लिए क्या करना पड़ेगा, f of t tr बाहर आ जाएगा, ठीक है। अब ये fx ऑलरेडी दैट इज इक्वल्स टू किसके बराबर है, fy के, सो नाउ आई कैन रिप्लेस विद दिस f of x विद f of y, मैंने रिप्लेस कर दिया f of y से, मैंने लिखा कि नाउ वी नो दैट f of y से रिप्लेस कर दिया, देन कीप इनसाइड दिस वन, इसको अंदर ले गया, तो व्हाट हैपेंड व्हेन आई कीप इनसाइड, तो इट्स बिकम f of ty, So again now you have proved f of tx equals to f of t by this condition. Clear? So
सिर्फ R तो नहीं आएगा ना
उसमें r अंदर ले गया ना,
ओके
तो ताकि क्योंकि you have to prove this one ना.
यस यस
Yeah.
रिप्लेस
Clear? So now the case 2. So take the example is here.
ज्यादा जुल्म नहीं हो गया दूसरे बच्चों भी तो नहीं आए
अरे यार एक एग्जांपल करने इस केस 1 की, फिर उसके बाद आगे केस 2 वी विल डिस्कस इन द कमिंग क्लास. चल ठीक है, ये एग्जाम कर लें. नाउ टेक एग्जांपल. यस HOD क्लियर ऑफ HOD है क्लियर ऑफ 2 ऐसे ही HOD ऑफ 2 degree 2. Now now they take different bundles, for example, and f of 1 and 1. Yes, so 1 square plus 1 square, it is 2. Clear? Okay, now take another kind of the bundle f 0 and 2. What about this one? 0 square plus square root square, again it is 2. So it has been proved that, so now proved the first condition, prove f11 equal to f0 2. So first condition, first condition of homotheticity. Now second condition is what? T equal to 3. Okay, 3 ले लेते हैं, 2 ले लेते हैं, whatever. So f of yes 3 plus 3 3 on the 3 3 on the 3. Am I right? Clear? So what about this one? 3 square plus 3 square, it is equals to 18. Clear? स्केल विथ 3 यानी यही हो गया ना, t से मल्टीप्लाई कर दिया विथ 3 से मल्टीप्लाई कर दिया. ओके, यही करते हैं ना ये, यानी f ऑफ t1 और t1 यही किया था ना. So that is equals to f of 3 and again scale with this one, तो 0 and t of this one. Clear? यही होगा ना. तो it was your दिस स्केल एंड ये क्या होगा एफ ऑफ व्हाट टी जीरो कॉमा टी this one clear both should be equal to each other ऐसे ही है ना
Yes.
for the homotheticity both should be equal to each other lie on the high level of the same level set okay you got my point so now it is your 18 and because when up again this one what will be this value f0 and 3 square root 2 am I right is what 0 square plus 3 का square 9 multiply by 2 9 2s are 18 you got my point substitute here 0 square and 3 3s are 9 and square root of 2 is 2 so 9 2s are 18 again lie on the same IC level set first level set was 2 second level set value is 18 and it may be less than 2 and something else clear or middle of 2 and 18 as well clear you can put 2 is here and calculate this one so now in case of the 2 your answer will be 8 8 you can put here 2 square when we multiply by this 2 so t is equal to 2 the 2 square plus 2 square 4 4 8 clear now again the same value of 2 is here so 0 and 2 clear 2 ka square is what 4 and this is 2 4 2s are 8 again you will have the 8 so in case when the value of t equal to 1 okay right t equal to 2 t equal to 3 so this condition is going to be satisfied clear
सर इसके कंटिन्यूएशन में लिख लें हम ये
लिख लो so this condition is going to be satisfied here
Yes.
so now it has been proved that the function is homogeneous so it must be homothetic the case 1 the case 2 what was the second condition is that if the function is homothetic but it is not necessary it is a homogeneous first ठीक है क्लियर ठीक है क्लियर हो गया ना बिल्कुल तो इट इज तो वी आर गोइंग टू डिस्कस दिस वन so that was from my side bhai I think in the coming class we will discuss the case 2 or second condition of homothetic functions and after this we will move forward towards the other topics so it is very long debate related to the microeconomic theory so आप लोगों को थोड़ी सी हिम्मत करनी पड़ेगी ठीक है इंशाल्लाह मिलते हैं कमिंग क्लास में थैंक यू सो मच अल्लाह हाफिज
नेक्स्ट